All right, so in this video, I'm just going to be going through the answers for module 2. Once again, apologies for not for losing that file and not having that yesterday, but I found out where I hid it, so I will be able to show what we went over. And in yesterday's meetup, we had talked about the kind of more general Python problems and the more general sort of Python troubleshooting issues that I've been seeing. And what I'm hoping this video will just do is to just go through this homework. And then if you have any questions, just email me and we'll be able to talk through any specifics on this. And once I get all of these graded, you'll have my feedback there as well for sort of specific feedback on your individual submissions. So with that, let's get started here. So the first part of this assignment was just looking at how to deal with sort of larger data sets that you have to aggregate, and think about how you're going to aggregate it to answer specific questions. So I had provided a couple of examples here where you have different types of visualizations that where binning and aggregation is inherent in it, things like histograms and 2D histograms and heat maps, and but as with really really any sort of visualization can be used with aggregated data. So you're not just limited to these inherently sort of aggregational visualization types. So here, as an example, we're looking at individual records of every single house, every single lot in New York City, and we want to be able to look at trends over time. So we have for each lot, we have the year that it was developed, or I guess I should say the year it was last developed, and we have so with that we could get an idea of buildings of when each structure was built. So so what we ended up with was something like this. And as I mentioned during 2 meetups ago, when we were first just previewing this assignment, there's something happening with the data here. So you could see that it's spiky and something appears to be off. And when we talked about this during that last meetup, we had realized that this is really a problem with data accuracy. So you could see these spikes are really coming into are really at the every 5 and 10 year marks. So before it looks like around sort of the 80s, you have like a bunch of sort of spike here for 80. I forget the exact. I think it's 85, where you sort of start getting smoother results, and then you have these spikes that happen before. And what the spikes actually do is really end up with lead you to a misleading visualization if you just naively plot it out like this. So we're looking at it by a year, and we have we have these spikes, but these spikes tend to display the point that that there's just that many more buildings being built in these earlier years than there were in later years. And while that is the case, it's not to the degree that we're seeing in this graph here, because we're aggregating one portion of the data and not the other portion. So this is a misleading visualization. And so so basically in this answer here, we could see first, just a few starting points, a few exploratory ways that we could, get an idea of how buildings are progressing over time. So the first thing that I chose to do was just to aggregate the data by 5 years rather than every year. So here we're grouping by just year built. And then I'm actually using some pandas functions here, this resample. Forget if I added I added resample here. So there's some links to the documentation there. And all I'm doing with this is sort of making this a 5-year aggregation rather than a yearly aggregation. Pandas has some really neat built-in resample functions. So I'm building mostly the same graph. There's still some spikiness, but it's less misleading, I would say. And so there's still, it seems like there's more structures that are being logged in the deciles rather than the every 5 years. So you don't want to trust these spikes that we're getting, but you could at least get a better idea of the general trend, where it seems like there's sort of an uptick of building, specifically sort of the Roaring '20s to the Great Depression, and then after the Great Depression during the wartime years, things sort of taper off a bit, and then taper off even further as we get to sort of more modern times, with kind of a slight uptick with current buildings being built. So, and this is roughly sort of the story of New York's development, as there was sort of that big boom in development during the 20s and 30s. So, so this does look a lot better, so we have this kind of strategy of just getting an idea of the distribution of building dates. And another strategy for dealing with sort of patterns of how buildings were built over time is by plotting a cumulative graph rather than just the raw values of what's being built. So this is similar to sort of if you're looking at probability distributions, and you have your PDF, your probability distribution function, and your cumulative distribution function, where one is just simply the integral of the other. And using it with this sort of data actually solves a lot of the issues we were having with spikiness. So what this actually gives us is and here I'm still binning it by year. But it doesn't matter that the data is spiky, because those spikes in a cumulative sense are seen as steps. So it's easier visually to ignore those steps than it is to sort of see data going up and down during when it's plotted out like this. And also what I did was make this essentially a percentile. So I have my cumulative sum over here, or rather, the cumulative sum is just simply sort of the sum that's building. Pandas has a built-in function for that, and and then I have this sum, so I'm getting a percentage there. So I'm basically starting out at 0 and then making my way up to 100%. And what this allows us to do is more easily see the specific answer to the question. So going back to the question is, we want to look at, look at sort of the earlier, when sort of the first buildings of a specific height were built. So this is all buildings, but what we're able to get is, essentially when we're like most of the buildings built in New York, to sort of get an idea of sort of a question like that. You could, and I intentionally left the question vague. I did, in terms of like, I didn't give a specific cutoff. And using a cumulative graph like this essentially means that viewers could pick their own cutoff, and they're able to essentially make that judgment for themselves. So if you simply wanted to say when when do we sort of pass that 50% threshold, we could say that, in 1931, that's when half of the current city was built, and then the rest of the city was built after that time. So this is what we have for all buildings. And then we have, something like this translates pretty easily to the way that I'm asking this question, where we're looking at different, in this case, I sort of defined deciles of building heights. And so what I chose to do with this is just simply do a sort of small multiples treatment of the data. So I have my 0 to 10, 10 to 20, all the way up to 50 and above. And with all of these, they're all they're all percentages. So these are all comparable. We could sort of look at these on the same axes like this and draw and be sure that we're drawing the right conclusion. And because we're using this because we're able to sort of use this cumulative strategy, we could answer this question for each of the building heights. So if we wanted to look at 20-story buildings, we could see that, and let's say we wanted to look at the first quarter, the first 25% of buildings. So, we're we could sort of look at this and say, maybe it takes, maybe that's the cutoff that we want to see in terms, how we want to define earlier buildings of a certain height. So if we, wanted to do something like that, we could sort of see 20-story buildings that are, you sort of hit that 25% threshold around 1939. With 30 to 40-story buildings, you end up not crossing that until 67. And then I believe you have similar numbers for the 40 to 50-story and then 50 and above. So here we're sort of a bit in the later sort of 1970, it looks like. And here we don't reach that 25% until 1975. So this does give us an idea of essentially which buildings to target. So we kind of map whatever percentage cutoff we're looking at onto a date, and then what we would do is simply look for buildings that are 20 to 30 stories that were built before 1931 or the 1930s, and similarly for the other building deciles. And this also just tells the story of how development is happening in New York overall, where as expected, there's as technology progresses, we're able to build taller buildings. If you do look at some of the some of these plots where you see sort of buildings kind of increasing over time, like even in a plot like this where it's not giving as much information as these cumulative sum graphs, you could still sort of see things like where, when elevators were invented, or when there were specific breaks in technology that allowed taller buildings to be built. So that's what I had for the first question. So the first question was, it had a bit more of, it was a bit more kind of thinking about the, question that's being asked, and really trying to think about strategies to display that information. But then the second portion with data shader was a bit more prescriptive. I I picked what I thought was a fairly interesting question to look at. Picked a pretty unique strategy to deal with that. So in this case, using a bivariate choropleth map. And really, this was just about kind of getting that first use case in with data shader. I just wanted to make sure everyone was exposed to something like this, because really this is a pretty innovative way to look at large data sets. So I think it'll only gain in popularity more, and hopefully this serves as a nice introduction for it. So the question here is, we're pretending we're a real estate developer, and we're looking at where are there opportunities for development. And one way that we could sort of look at this is you have some sort of value of land. So land closer to the city center is more expensive than land further away from the city center, and you want to and in general, if land is more valuable, it's going to be uh, more intensely developed. So if you have land in the center of a city, that's why you have skyscrapers versus more multifamily homes or single family homes as you get further away from the city center. And what this is sort of looking at is just looking at the city as a whole, and so yeah, we have these separate measures of sort of land value versus structure value. Although actually, it's I believe it's yeah. I had so we have assess total and assess land, and with that we could get the assessed structural value just by subtracting them. And with this information, we want to get an idea of what this will give us is, first of all, areas that might be overdeveloped, so areas where the land isn't the land value isn't as expensive, but the structure relative to the land is more expensive. And then, more importantly for a real estate developer, looking at areas where there's high land value but low structural value, which implies that this land could be further developed to more intensive uses. So, so looking at this, the and sort of the method I had wanted you guys to try out was this bivariate choropleth map. It's and this this more was just kind of an interesting strategy I've come across that I thought led itself very nicely to a in this case a categorical data shader plot. So as I mentioned here, like when you do have these dense plots, you're able to really nicely define geographic information, but or nicely plot geographic information. And what we're looking at here is essentially treating these scales as a categorical scale and just simply running through the exercise of plotting this categorical data in Data Shader. So what I ended up getting is just essentially dividing the data into these sort of I just divided it into thirds, and kind of coding it based on what percentile comes in. So I'm sort of calculating my percentiles here, and then I'd mentioned in the documentation, and I didn't go through this yesterday really, but pandas apply is one function that that I think you sort of come across a lot in terms of pandas, and it's a really sort of with R and with R you have the original plier library, which does a lot of this what's called split, apply, and combine methodology. And apply is really the sort of one of the ways that you would do that with pandas. And this is a bit simpler than sort of the full split, apply, combine workflow. It's really just applying sort of a function based on some other data. So here, all we're doing is sort of using these percentiles to get our land three tile, our structure three tile, and and then sort of combining them into a categorical and I just made it a string, so just making it sort of two numbers and a string, and then this is pretty clearly seen in the example of the census visualization with Data Shader. So I know the data shader documentation isn't the best, but I tried when I can to really make sure that the relevant examples are linked to, and hopefully just by going through these, it'll give you that that feel for the data. So really, what I'm sort of the reason why I included this link was because of what we're doing with the racial map here, where you're able to see this is just looking at American Community Survey participants and just a dot for each person. So you end up getting detailed maps like this when you're looking at categorical data like that. So here I'm just sort of building my color key. I just manually grab that from what we have at the end here. I believe I'd mentioned in the in the questions in sort of the notes here that I haven't really found a good way of labeling data shader pictures. Data shader is, I believe, meant to be used more intensely with sort of the bokeh ecosystem, and I think with some visualizations there, like they allow you to add that. But for now, just creating the image was fine, and I just sort of included some notes of where of what we're looking at, and then we're basically following the data shader pipeline, defining our canvas. Here, I'm sort of using this New York City dictionary, which I defined up here. And this is very similar to what we were doing over here. Like we just define our canvas using the New York City dictionary. Using this sort of star lets us kind of add those elements as arguments, and then we have our points that we're adding. So it's just looking at latitude, longitude, and we're using a data shader function to access the 3 tile. We also have the shading, which we're doing with the color key. So we've sort of mapped our categories, and we're now adding the color using sort of building on top of this ag object, and then viewing our results. So and then sort of trying to get a feel for what we're looking at here, as expected. So here I kind of in the notes you have greener where assessed land is higher than assessed value. Redder means assessed, that should be assessed structure is is greater than the assessed land relatively compared to the other. We're basically sort of using this since we're using percentiles. We're sort of doing this on a comparative basis. And maroon means both are high. More white means both are low. And we definitely have kind of an interesting distribution here. You see clear areas of so sort of in this belt over here we have our redder areas where these are perhaps overbuilt. We have structures that have higher value than the land relative to the other sort of structure land pairs. We have some areas where when we're sort of greener, that's when assessed land is higher than assessed structure. So we have sort of we have a lot of areas closer into the city. We have maroon, so areas like Manhattan, it's very it's just highly developed and has high structural and land values. And we have some areas where you could see sort of some white. You could notice some kind of more complex patterns. Like I'm not exactly sure why the Bronx sort of is seems so mixed, where there are clear zones in the outer boroughs here. But just to kind of summarize, this is roughly what what I was expecting out of this, and it was just meant to be sort of more prescriptive based on using this categorical information here. So thank you for listening to this, and if you have any questions, just contact me directly and I'll be able to help out. Thanks a lot. Bye.